In this video, we are going to experiment with using n8n as a design tool for developing applications. We will use n8n with Claude Code to convert a workflow that we design to a .NET Framework Web API application. Our task will be to create an API in C# that will expose endpoints that allow us to query data from a Microsoft SQL Server database. Let us start by taking a look at the database and queries we will be using to provide data to our application. We will be using the open-source Wide World Importers database that is supplied by Microsoft for our application. The database schema represents an enterprise resource planning application used to drive an e-commerce website. We are going to provide customer, supplier, and transaction information to our application. For this, we will be using predefined views in the schema. The first endpoint will supply general customers view from the website schema in our database. For demonstrative purposes, we will select only 10 records. For our suppliers, we will use the suppliers view, also from the website schema. For our transaction data, we will query the customer transactions view from our reporting schema. We will order by the amount excluding tax value and select the top 10 values. With the data selected for our application, we will now begin using n8n as a designer to provide context to Claude Code from workflows to generate our application. First, we will start by adding a manual trigger so that we can execute our workflow. We will then add a Microsoft SQL node to our workflow and provide the SQL from our customer's query. Our credentials are already saved in n8n, which contains the query string parameters used to connect to the database. We paste in the SQL statement we are going to use for the query, and we will execute it to see the results. Here we can see that the expected results are returned from our workflow node. We will rename the Microsoft SQL Customers Query node to give our workflow contextual meaning. We save our workflow as a good practice after we have added our node. We are now ready to add our next query, which will come from the suppliers table. First, we will detach our trigger from the customer's query node. Then we will add a new Microsoft SQL query node. We paste in the SQL statement from our supplier's view and likewise execute the query to make sure we get our results. Again, we will rename the node, this time to Microsoft SQL Suppliers Query, to give our workflow contextual meaning for its nodes. After saving our workflow, we can add our last query for top transactions in a similar manner as the other queries. Now that we know our queries are returning the expected data, we will organize our layout and remove the manual trigger from our workflow. We will be adding webhook nodes that will be used to generate the API endpoints in our application. Webhook nodes provide us with URLs and listeners that we can use to trigger our workflow steps. We will attach our webhook trigger to our customer's query node. To test our webhook, we will first need to listen for an event so that the endpoint receives and responds to HTTP requests. We are using a GET request for this webhook. We will copy the URL for the webhook trigger so we can issue HTTP GET requests to it. We will use Insomnia as the tool to issue test requests to our webhook. We will paste the URL we copied into the endpoint URL field and set the method to GET. The response from our call is the standard response returned by webhook nodes. Workflow has started. This confirms our webhook listener received our call. For the remaining queries, we create webhook nodes, attach them to our queries, and name them to give them contextual meaning. We are now ready to start with our code generation using Claude Code. We will be using Cursor to interact with Claude Code. We start a new empty project with an initialized Git repository. We will create 2 empty directories in our root folder. One will be called docs, the other src. We need to give Claude Code some initial instructions so that it can efficiently create our application. The following Markdown document describes the system prompt that will be used for the context. You are an expert C# developer familiar with best patterns and practices. Your job is to develop prototype applications that reflect a minimum viable product. A minimum viable product does not require extensive tests to be written or large amounts of configuration. Your focus will be on converting n8n workflows via JSON files to .NET applications that will accomplish the same task. Some examples of such would be conversion of n8n webhooks to ASP.NET Web API endpoints, conversion of JSON passed to and from webhooks to request and response data transfer objects, conversion of n8n nodes that validate, write files, etc., to similar C# classes that will accomplish the same task. We also provide some basic information such as the solution name and instruct the LLM to use the project name as the root namespace. We provide the stack, along with information about the directories we want to create the project in and define some naming conventions such as the name of the exported n8n workflow JSON file, which we will name workflow.json. We also instruct the LLM to create a devplan markdown file. We will use this markdown in a new file named initial.txt in the docs directory. After providing our instructions, we are ready to start using Claude Code. We open up a new WSL terminal and start Claude Code. Once Claude has started, we issue the /init command so that Claude will generate a Claude Markdown file to use as our context. Here is the generated Markdown file which Claude created based on our initial.txt document. Our document contains sections for the project overview, the key conversion goals, the technology stack, and the project structure. Note the key conversion goals section. This explains the pattern for our application code based on the input from the workflow.json document that will be added in the next steps. We can see that Claude will read n8n nodes and apply the following patterns when they are encountered. For webhooks, create ASP.NET Web API endpoints. For JSON payloads, create request and response data transfer objects. For other nodes such as validation, file loads, etc., create classes with the equivalent functionality. The next sections contain information about directories and .NET commands used to create and build the application. Our development workflow section describes the discrete steps that will dictate the application development. It explains the inputs, instructs the LLM to convert the n8n workflow progressively, starting with the controllers, moving on to the data transfer objects, and then to the creation of C# classes where any additional functionality is needed. The last section of our document, Architecture Patterns, describes in detail the C# assets that will be created for different n8n node types in more detail. We will open up Claude Code in the WSL terminal and give it the prompt. Let's start the project. We can see that Claude has read our dev plan and is now looking for our workflow JSON file. Let's provide it. We do this within n8n by clicking on the ellipses in the top right-hand corner and selecting Download from the menu. This will export the JSON file representing the workflow, so we can use it as input to Claude Code. We will create a document called workflow.json in our docs folder, which is the convention we specified in our initial instructions, and paste the contents of the JSON file we downloaded from our n8n workflow. Briefly looking at the n8n workflow, we can see that our select statements are included in the file as Microsoft SQL nodes. If we look toward the bottom of our file, we can see the declaration of the webhooks that Claude will use as guidelines to create our web API methods. We will open up Claude Code and tell it to continue our project now that we have included the workflow JSON file. We instruct Cursor to continue our project and give it permission to execute required actions when prompted. We can see Claude is generating our data access objects. Claude is now generating our service layer. Now we see Claude is generating our controllers. We are informed Claude has generated our application. It successfully builds and provided the next steps, such as updating our connection string. If we look at our generated project, we can see that the controllers, models, and services appear to have been generated per expectations. We can also see that our app settings.config file contains a connection string for our database. Claude specified an integrated security connection string because it does not have access to the credentials for the database stored in n8n. Claude informed us that we may need to change the connection string in its generation summary. In our case, integrated security will work fine. Let's launch the API project. We see that launching the application also launches our browser, with the default page set to our Swagger index. From the sample response, we can see that Claude has generated the expected response types. Let's go ahead and execute our API GET request for the customer's endpoint. We have received an error response. It is not uncommon to encounter these after a first pass at application generation. There are often additional steps that you will need to take. After debugging the error, the cause was isolated. In our customer's view, we have a column called delivery location that has a geography SQL Server data type. Our object relational mapper does not know how to convert this type to a standard .NET value type. For the purposes of demonstration, we will remove this column from both our query and our DTO in the application. Let's go ahead and execute the call to our API endpoint again. This time we can see that our response is returned as expected, with the data from our customer's query returned correctly. Suppose we want to take things one step further and generate a user interface for our project. Let's give it a try. For a prompt, we will simply use generate views for the controller methods using MVC in the application. We see Claude understands the requirements and is ready to start generating the UI. We will give Claude the permissions it asks for in order to run the necessary tasks. After completing the generation, Claude gives us a summary, documenting the created views and URLs. When we run our project, we can see that Claude has generated a user interface for our API. Here we see sections for the customers, suppliers, and transactions. Let's open our customers section to see the results of the generated page. We can see that Claude has generated the view using a tabular layout for the customer data. Now let's look at our suppliers section. Similarly, we see a tabular layout for our suppliers' data. Finally, let's head back and take a look at our transactions section. Again, we see a tabular layout with some style applied to our status column. Hopefully you enjoyed this demonstration and it gives you some ideas about how you can use n8n to design your own application. Keep in mind, n8n allows for many more features such as logic blocks, file operations, data mapping, and so much more. Thank you for watching.